Good day, everyone. I'm Bob Ackerman, the editor-in-chief of Signal Magazine, and I'd like to welcome you to our Signal Media webinar titled Beyond Stovepipes, Video Distribution for Today's Missions. In today's webinar, which is sponsored by AFCEA, three experts will discuss how long-favored legacy video distribution systems have become vulnerable and how military organizations can strengthen and modernize them using new technologies and capabilities. This presentation qualifies for one GIAC or CompTIA continuing education unit. Now, those of you who have participated in past Signal webinars are familiar with our audience interface. Throughout the presentation, webinar attendees are encouraged to submit questions electronically through the Ask a Question box on the webinar console. When our experts are finished with their presentations, they'll answer as many questions as time permits during this hour-long session. Also, the Resources tab offers resources to attendees throughout the event. Today's first presenter is Howard Sutton, Executive Chairman of AFCEA. With 4 decades of experience in technology companies, Howard is well-versed in corporate investment and innovative technology exploitation. Joining Howard as a presenter is Scott Barella, Chief Technology Officer at AFCEA. Scott has a long history of audio and video distribution expertise, and he helped develop the standards for AV over IP. Our third expert is Dennis Defensor, Vice President at AFCEA. Dennis's long background in the arena is flavored with extensive expertise in government contracts with an emphasis on information technology. So with that, I would like to turn the presentation over to Howard Sutton. Howard?
Well, thank you, Bob, very much, and thank you, everyone, for taking time out of your busy schedules to join us today. We're going to take you through some information. Scott and Dennis are on the virtual podium with me, and will try to keep me on the straight and narrow, which is difficult to do at the best of times. But the topic today is Beyond Stovepipes, Video Distribution for Today's Missions. And that title, we really think about and conjures up the reality of a rapidly advancing set of user requirements, requiring adoption of new capabilities. But the term stovepipe, is an archaic, dated, name representing an architecture or a technology. But history is a great, it's a great instructor. Lessons learned from past, can be applied today and into the future. So I want you to think back to your great-grandparents. They would have used stoves and stovepipes in their homes. It probably was one of their prized, possessions. And they lived within their 4 small walls of their home at that time or farmhouse, and it provided warmth from the cold and in winters, and it was an appliance to cook meals and boil water, from the well. And they were happy. Now picture probably about maybe 100 years ago, there was a knock at your great-grandparents' door, and it was someone selling electricity. New and novel, an innovation. And soon electric appliances and a furnace, would displace that beloved family stove. Think about not long after that, another knock at the door. And your family's introduced to the world of telecommunication through a Bell salesman. That's a game changer. Technology evolves, requirements evolve, and it's this constant dynamic symphony of this interrelationship and interdependent capabilities between technology and user requirements. So if history really is any guide, our world today is being played out listening to that same symphony. VDS technology and government requirements, as we all know, they are evolving rapidly. And while stovepipes met the needs of our ancestors and the needs for a lot of our functional requirements to date, they have to be reevaluated constantly. So the knock on our door is the rapidly advancing technologies to meet the ever-increasing demand and capabilities demanded from our community. So that's what the topic is today. Beyond Stovepipes is placing technology and innovation at the crossroads of evolving user requirements. And, we really think, PACE is in a unique position to talk about this because PACE for decades has built those stoves and continues to build those stoves. It designs and manufactures baseband routers. That was the go-to technology. And possibly maybe some of you have indeed used PACE routers. We have a deep understanding of that technology. We understand its strengths, and we also understand its weaknesses. The other side of the equation is PACE also designs and builds Secura, which is an ultra-secure IP video VDS-based platform. And it was built upon listening to you, our customers, and the lessons that we have learned on designing and building solutions. So when we refer to Stovepipes, we're looking at the legacy environment, and in many installations, the current environment, and we're not trying to present a biased material. We're in both camps, but yet we want to share our knowledge. We want to share our experience for mutual gain, and we want to continue to learn from you and our customers on needs and requirements going forward. We're always eager to learn. So with that, we're going to talk about the VDS, the stovepipe. We're going to talk about legacy systems and kind of where they stand and what they're good at and maybe what they're not so good at. New technology, best practices, and then most importantly, hopefully a nice session of Q&A. So just so we're all on the same page, let's just start with the basics of a VDS system at the most simplest structure. You've got inputs, a variety of video and audio inputs, sources, and you have a switch that switches those to destinations, whether it be displays or other computers. It's a simple, at the very basic level, it is a simple input-output system.
Yeah, Howard, this is Scott Varela, the CTO of PACE. I thought I'd interject some comments from time to time here, seeing Howard's wonderful presentation. But yeah, I like this slide in the sense that you can see all the inputs to the left and the outputs to the right. This goes to your stovepipe question. This is how we've done this for decades, where we have a number of inputs to a defined grid, if you will, and then we can distribute them from left to right. We can send the camera where it needs to be shown on the monitor. And as such, as it says below, it says a defined frame capacity. One of the things that's kind of frustrated us over the years is that limitation.
Yeah, thanks, Scott. So here you have it, a bunch of sources going through a traditional matrix router to workstations. They are reliable. They are very reliable, low latency, and very much hardware-centric, hardware-based. And that really came about because it had to be, for many decades, custom hardware to meet the requirements of low latency and the resolutions at the time, which were considered, high and getting higher. But, today, 720, 1080, some 4K P30, and includes KVM. And secure KVM switches also fit into this type of environment. Closed room, campus type setups. That framing around the picture is pretty much can be considered a physical wall.
Yeah.
Small to hundreds of endpoints, plug and play. A lot of these systems were initially designed alongside in broadcast, right? So connect anything and make it make it work. Security was not part of the thinking in the architecture. It was ease of use and plug and play. So the environments today require physical security and 100% trusted users, and that's been the operating environment, right, Scott?
Yeah, it's exactly it. So, as time went its merry way, and this is over the past 60 or 70 years, these devices obviously changed in resolution and frame rates and all that sort of thing. We were able to keep up with it all, but at the end of the day, we basically invented that red box. We had to invent that red box because it didn't exist, kind of an off the shelf. So we got busy in creating standards around that idea, and they were all based on signals that were very unique to video and to audio. And that's been true for a long, long time.
So Dennis, do you want to just comment on sort of the typical operating environment? Dennis, you may be on mute.
This is a perfect. Can you hear me now,
yeah,
Howard?
Yeah, can hear you now, Dennis. Thank you.
Sorry about that. This is a perfect slide to show exactly how things are today. You have a VTC, you have a command and control, you have an op center, a Navy CIC. Now these are separate venues that are independent of each other, and that's the way things are right now. They're effective, but they're stovepipe. With PACE and Secura, you can envision a joint all-domain environment where your op center and your C2 and your VTC in multiple locations can actually be connected into one interwoven command and control center. This is the power of distributed command and control that Pacer brings to the table, and the first one in the industry to do that and enhance the value of the current need for a more encompassing command and control environment that actually connects all these possible scenarios.
Thanks, Dennis. So a stovepipe VDS, this in fact goes back to the Department of Energy back in 1999, but it's characterized by a limited focus of functionality containing that data that cannot be easily shared with other systems, and that is the stovepipe. A lot of the way, as we've just said, this is a result of a requirement. Primarily resolution and latency had to be hardware-based, matrix-based switchers. There just wasn't an alternative for decades.
Yeah, to add to that, Howard, PACE has been involved in that very beginning of these early VDS systems where, not only the Department of Energy, but for the Department of Defense needed, some guidelines, and we were able to help author parts of the DISA approved products list, and we helped them along with the video distribution system. And it was mainly because of the expertise PACE had in these early stovepipes.
Thanks, Scott. So solutions are available based on technology. We all know it's baseband, it's uncompressed, so it's high bandwidth. You need 12 gig for 4K 60, 6 gig for 4K 30. So you're dealing with big pipes here, and great solutions were put in place using this technology. It shouldn't be discounted. But as we talked about the symphony of interrelated, evolving technology and user requirements, the world has changed, and it's changing rapidly, and the requirements are being forced upon VDS architectures, distributed workforces. These are just but a few. The whole issue of threats, whether they are internal or external, the need to connect up to millions of sensors of information that are driving real-time AI platforms for real-time decision-making. We've got a bunch of platforms, similar like JADC2 or ABMS or Project Overmatch and other platforms that we have to work friendly and work together in the same sandbox. Issues of disaster recovery and backups and redundancy. Clearly COVID, with the COVID issues within command and control centers that could cause disruptive events. So how can we rapidly, without any disruption, maintain our status when there is a physical disruptive event caused by COVID?
Yeah, clearly, we have, that many sensors, millions of them, and various of them are data points and non-video pieces, right? But video plays an important part of that. So pieces of the old stovepipe don't exactly match with some of the new data pieces. So that's where the rub starts to begin, where we try to interlace, video information and audio information and other pieces of information where they need to be transported along a common platform. So the need for bringing this to today's missions is pretty important, and it's changing as we speak.
So we know the strengths of the architecture, and there are many. But this architecture is incapable of meeting future needs. And what we've drawn here on this slide is some elements that are required. They are required in the world going forward. It's the bell salesman knocking on your great-grandparents' house with communications. We have and require and must have distributed environments. We must have security from source to destination throughout. Cloud enablement. These are must-haves. Encrypted. Baseband, you cannot encrypt baseband. We have to have collaboration. So all these elements are key, and it's just not part of the baseband architecture.
Okay, well, we would like you, the audience, to join us in a poll question. If we can have that reappear. What do you see today as the most significant or largest? Let me get my poll question back here. The most significant or largest limitation within your current VDS? Scalability, resolution, external threats, networking capability, collaboration, or internal threats. If you could please check off which answer applies. Howard, let me just ask about security, because I don't want to steer people toward one answer or another here. As video means proliferate and new forms of networking come online, where do you see the biggest security threats coming from?
Yeah, Bob, that's a really interesting question, because there's been a lot of work and papers written about that. And the focus, and you hear about mostly in the news, is state actors, threats that are attacking your network, and we hear most about that with regards to cybersecurity. But indeed, a very, very high number of exposures are as a result of internal. It could be malicious actors, internal, or it could be accidental. They have accidentally accessed information because there wasn't the policies and structures in place internally to keep them from accessing that information. So security involves technology, and involves much more than technology. It's processes, it's audits, it's oversight, it's education. But any single link, weak link in a chain, creates vulnerability. So that's why I'm interested to hear on the poll if indeed security is an issue. The difference between 3 and 5, external and internal, Bob.
Okay. Well, let's put the results of our poll out. I hope it wasn't because of our discussion, But external threats topped the list with 55.6% of our respondents saying that that is the most significant limitation within current BDS. Internal threats came right behind that. Halfway, actually, 22.2%. Networking capability or collaboration and scalability both came in at 11% each, and I guess resolution did not show up. So that's an interesting point, though, that external threats by far dominated in a strong majority. What are your thoughts there, Howard?
Well, I think it's interesting that 77.8%, if you add external and internal together, it's a dominant theme, and we're going to talk about that further. There's a lot of our content going forward has to do with that. So I'm delighted with that response because we're going to be talking about that the majority of the balance of the presentation. So delighted.
Okay, well, please continue.
Look at that. That's almost a plant of a slide. Problem with baseband, it was never intended to be secured.
Absolutely.
It is an open signal. You cannot encrypt baseband.
Nope.
Just as an aside, PACEA years ago with its baseband router, was looking at filing patents and looking at technologies and ways to encrypt. You can't encrypt the signal. It flows. Yeah. And I love these slides because that's basically what happens. You unplug it, it continues to flow all over the floor. And you got to mop it up. It's vulnerable. It was never designed. It was never designed for security. So it's just a problem with that architecture. And that in fact, if you want to know the absolute truth, was the reason PACEA commenced in 2017 to build what we're going to talk about going forward. I do want to just communicate with Scott and Dennis the baseband certifications because it's important to understand the certifications and how it applies to security. Vendors, including PACEA, have gone through these certifications. Let's go through them very quickly. Common criteria. Watch for the self-authored security target because that is basically you're writing your own document to be tested against. How common criteria has fenced that is to say that if you have no protection profile, independent of what you say you are, EAL3, EAL4, EAL5, the maximum you are is EAL2. Security targets for baseband systems traditionally are written, and if you look at the security targets, they are written and emphatically state within that security target 100% trusted users and require physical security. Why? We've just mentioned the reason why. All the signals are viewable. Plug it in and you see it. Everyone has to be trusted. So now we look at Tempest. Tempest, as many of you know, is an electromagnetic radiation testing. It has to do with the emission of electromagnetic waves that can be snooped and picked up, as well as crosstalk within the frame of the router. PACEA has a lot of experience with this because we've built large routers.
Yep.
Please ensure, when you're looking at Tempest and any certificate, understand under what condition that frame was tested. Because if you have a large frame and all it is plugged into the wall with no signals going through it or no cards in it, or one or two signals going through a 864 size frame, the amount of electromagnetic radiation emitted depends on the signals being passed through the frame, through the wires, density, through the input board, through the matrix board.
Good point.
So it's very important to ask for, if you're putting in a big router, ask to see the certificate and the configuration of the test.
Yeah. Yeah, it's pretty easy to do a 101.
VDS,
Go ahead, Howard. Sorry to interrupt.
Thanks, Scott. VDS DISA that ties in to the same criteria as common criteria. The DISA is testing in a closed environment. Control system now is IP, but you're still dealing with baseband audio and video. NIAP, as it's come up for KVM secure switching, it is a closed environment. It's to isolate the signals. It's not networked. A lot of these are desktop-based systems which will have locally connected computers to locally connected workstations. It's not a network-based. It's a few to a few type of connection. So just a little bit of clarity on that. Scott, did you have any comment on that?
Yeah, I was going to say that the KVM PP is primarily based on baseband. So, we're still into the same problem. You can't secure baseband. And when we're talking about baseband, we're talking about, just raw USB or raw HDMI or raw serial digital interface, what we call SDI. All of those are kind of traditional stovepipe type signals. And that's what, most of these certs are centered around, frankly.
So now let's take a look at IP. IP up to a few years ago, because of the resolution and latency requirements, it was too expensive, or the codecs had not evolved enough to be able to match baseband requirements. That's changed. So what we have now in a traditional VDS platform is the requirements and the usability of taking sources and moving them to destinations is the same. Mm-hmm. But it's now an environment where, through technology and the capabilities of IP today, you can have low latency, the same reliability. 4K P60, you can start at 4K P60 and go up from there, because you're dealing with visually lossless compression, and you're not requiring the full bandwidth. Once again, remember, 12 gig is uncompressed 4K 60 in baseband, and depending on the codec, you're down to anywhere from 10 megabits up to, depending on the codec, once again, up to 800 meg. But you're not at 12 gig.
Yeah.
Scalability, encrypted, safe and secure, USB. It's what we're going to talk about is quite frankly the advantages now of IP. Clearly, in distributed environments, it scales. We talked about millions of sensors. IP has that capability. But not all IP fits the bill. So here's a little bit of a framing, putting gates around it, right? Core IP allows you to do a lot of things that baseband can't do. You can cloud enable. You have distributed. Think of the data environments, right? You have encrypted data. You have enhanced collaboration. You have scalability. There are unique requirements for video that require slightly different implementations and architectures. Easily can bring down your network if it's not done appropriately. But you are now into the world of off-the-shelf hardware. These aren't proprietary PESA routers or a competitor's router. You can buy Cisco or Arista or your Juniper. You're working off just a very, very different platform. But in the yellows, you'll notice that there are still some unique things for video that has to be done properly, especially when you're dealing with mills, multiple independent levels of security, the idea of authenticating everything, everybody, every device in the network, securing it with FIPS crypto, etc. These are things that have to be done if you indeed want to implement IP security. You just can't buy an IP platform and implement it. So what we're going to do, basically, is take those boxes in yellow and we're going to attack them. But just before we do that, you may be aware of the cybersecurity executive order that came down in May. This is big, and it's big, but it's not unexpected. We need to secure our nation's assets. And we need to move towards zero trust. Zero trust. Not 100% trust that's in our baseband environment. Zero trust. And we need to move towards, cloud initiatives and collaboration and distribution. That's across the board. That's just not VDS. That's across the board. So I see there's another poll question, Bob.
Okay. Not too many options here. This is a straight up or down. Are you being asked to add security to your VDS solution? Yes or no? Just two ways to answer that. Are you being asked to add security to your VDS solution? Now, Howard, I'm going to ask you why this question. What is the sort of situation that you have that would present the need for this question being answered?
Yeah, so the reason why we brought this up is somewhat audience dependent, Bob, but traditionally VDS has grown up independently of IT and IP. So VDS engineers traditionally have been a separate group from the IT/IP group. Historically, it's been the IT/IP group that has been required and focused much earlier than the VDS group on security. And the reason partly was because of technologies we've talked about before. The technology within VDS required custom hardware-based solutions, and they were not networked, they were isolated, they were stovepiped. But now organizations are coming together. VDS engineers are working with IP engineers. It's part of the same community. VDS is just a form of data. So what we thought by this question, Bob, was we get a sense of, is the VDS organization, how much is it now integrated with IP and the push to add security, or is it still being rather, I don't want to say marginalized, maybe the wrong term, but allowed to operate independently within the 100% trusted user, 100% physical security requirement?
Okay. Well, our audience is split right down the middle on that. 50% yes, 50% no. Perfect point for you to elaborate on the whys of the yeses and the whys of the nos.
What's interesting, Bob, is that's really quite representative from what we're hearing from our customers. When the electricity salesperson knocked on our great grandparents' door, there would be a lot at that time that would say, you know what, I'm absolutely fine. My requirements, I don't need anything more for now. I've set up my environment, my processes, my kitchen's warm. I like to cook on that stove. I'm used to it. I grew up with it. And that's absolutely fine. But over time, what happens obviously is the pressures and the requirements force adoption of technology, in this case electricity, to buy a new stove to make life easier, will happen. I mean, we firmly believe that over time, and it's going to be over time, baseband will be marginalized. And I want to reiterate, we're not saying this from a bias perspective, because we build, and the PESA has grown itself. Its company has been baseband routers. But we do believe, based on the requirements are going to demand the change. It's going to force the change, because the world is beyond 4 physical walls, and the world, unfortunately, cannot have 100% trusted user once you go beyond those 4 physical walls, or even in some cases within those 4 physical walls.
Howard, this is Dennis. Another factor too is that in any C4 ISR or C5 ISR architecture, VDS are the eyes and ears of the centers. So you don't want your adversary being able to see what you see and hear what you hear. and it resonates not just in DoD in terms of national security, in the global economy. The head of our Federal Reserve has said that cybersecurity, basically security, is the biggest threat to global and national economy. It's beyond just national security. It affects our daily lives.
Thank you, Dennis. So we're going to move on. We've got about 10 minutes left, and then we want to leave lots of time for questions and discussion. So we're going to talk about implementing zero trust versus 100% trust. With the understanding that even in IP, without proper security, your information in a network can be changed and altered and disruptive. Airplane on the left, satellite picture, no airplane on the right showing up, but in fact, it's been altered. So it's really, this is a setup for, I'm going to pass the podium over to Scott, and if you'll notice in the top right corner, we're going to go through some of the elements, or actually all the elements that were exposed in yellow on the earlier slide that really need to be focused on. So over to you, Scott. Thank you.
Thanks, Howard. Yeah, so basically, my lead developer was working on an application for one of the Department of Defense's entities, and they came to him with a wonderful application for this particular enclave. And they said, okay, we just want you to sprinkle the security dust on this guy, and we can get this app off to the agency or the enclave, and away we go. And he said, well, that's nice, guys, but you're going to have to start all over again, because the way we do proper security is that each of these bricks needs to be placed in, and we consider the brick to be this FIPS 140-2 crypto module. So in essence, where we started at PESA with respect to getting this whole thing going is, in fact, the part that dictated that the NIST certification be complete. We call this a CMVP module, and as such, we have ours, which was just granted to us this year as a CMVP number 4021. This module will be used throughout our new application, so that every piece of communication on the wire is done using some authentication from signal point to signal point. And that's absolutely a must, because this is one of the requirements that the Department of Defense mandates. So we figured that we'd start there. And then as we did that, we built the bricks around our applications as we moved forward. Now, of course, parts of this is mutual authentication. So not only, and some of you may be familiar with HTTPS, a protocol that's used widely on the internet, where you, as a user, can trust sites that use HTTPS, because one side is actually telling you that it's okay to wander through its website securely, so that you weren't snooped and so forth, that your interaction is but it's missing one half of that. So what if that web server came back to you as the user and said, I need to know a little bit about you before you wander into my website? Now, a website is pretty insecure to begin with, and I'm picking on it because it's an easy analogy. But in mutual authentication, we need to be able to make sure that all of the objects that are interacting to make sure that the video and the audio are securely done, they're both authenticated, both the sender and the receiver and the controller that's telling and dictating those connections between sender and receiver. So mutual authentication was a real key part of how we were going to actually manage this. And part of this is pretty straightforward. These are done with CAs. These are commonly used throughout DoD and other agencies in government, and other agencies that are not government. So these certificate of authorities are checked back, and the process goes to make sure that in each half, not only does the server check the user, but the user checks the server. So we have a mutual exchange of certificate information, so that we both know that we're on the same page and that we can both trust each other. And this kind of goes to the point that Howard made earlier about zero trust. So in here, we started to also imagine that, not all signals are created equally, and that we have top secret, for example, on the yellow tier here. Those might be top secret. In the middle, we have maybe classified or slightly lower. Maybe those are the guys in red. And we have the black, unclassified or common signals that we can exchange freely with one another. And we might want to keep these separate. But it's important to understand that not only do we have device and signal information, but we also have users that have to be authorized as well. So we don't want to show a certain video to people that are not authorized to see it. We also have different groups that are involved in these missions and so forth. And areas, right? We might have a SCIF that's designated strictly as classified information. So we have to keep this into our design portfolio. The other thing that's often overlooked is how we are going to manage common networking. So in our network fabric, we have to know what signals are being routed from what switch to another switch through potentially a spine. So we have to have some measure of software-defined networking so that we can allow low latency, we can allow multiple resolutions, and we have some measure of quality of signal, so that we can make sure that the payload gets from point A to point B safely and securely through the network. So I have to have a mechanism in this part of our of the design in a modern VDS that's secure. It's done fairly traditionally, right? So we still have a data plane of essence where we have audio and we have video and we have potentially USB to move from point to point. And then we have control from north to south. That's very traditional. But what's new is the way we do that north part, right? So more of it is being dictated. This goes to DevSecOps, for example, or ABMS. That goes to the Overwatch piece. That also affects other pieces and entities that are looking at cloud structures to architect these million pieces of sensors, information, so forth. So when you read about the Department of Defense asking Microsoft or AWS to help them out with the cloud infrastructure, we know that's going to be a very important part for deployment across large scales, or even in scales where we want to keep that very tight, very, very secure. And so the beautiful thing about a cloud architecture, whether it be Kubernetes or Docker containers or any of the parts and pieces thereof, is we can install those on bare metal, or we can put them in cloud or data center operations. So we got a flexibility there that's very important to make sure we have. The other piece of this is that the Department of Defense has dictated some rule and guidelines about how we communicate from container to container. Now, this is going into the weeds a little bit, but there are rules about how we're going to use these cloud infrastructures. And they're not just willy-nilly rules, they're very important rules. And they go to the same exact pieces we had just mentioned: mutual authentications, certs that we trust, and having pieces and parts of each container that have to talk to one another, basically that they're secured for communications to and from, so that bad guys or people that are meddling can't get into them inadvertently. So some of the pieces here is that we have FIPS modules and all the IP signals. For mutual authentication, we'll need keys and certs. We'll also have to keep track of multiple independent levels of securities for classified, unclassified, secret, so forth. And we'll have certificates as dictated by the agency or the enclave. Right, so certain agencies will have different requirements and different ways of going about that security. So we have to be very, very sensitive to making sure that the platform is wide enough to cover it all. So the next transition is how we do the certs, right? So obviously I mentioned one of them, which was the FIPS 140, but we know that CC and NIAP will be a part of this. DISA certainly has a role in this, and our IP switches, the switches that we chose, are going to be very important. And so PESA took the very forward look of saying, okay, we know this is complicated, we know this is involved, so we'll bring the network with our solution so that we provide the networking solution with these endpoints as a complete end-to-end turnkey type solution. And that's very important for all the certifications that are involved in the disparate pieces that we're trying to glue together. It's very important that we have all of these things tied up so that we don't leave a stone unturned, so to speak, or a loose knit so that the whole thing comes unraveled. So, these are the kinds of pieces that as we check through those yellow cloud pieces, we have them all checked off. And Howard, this goes to your point about the stovepipes. As we move forward, this is how we would have to have a IP solution architected in a manner that satisfies all of these pieces that we know are going to be coming up front and center for not only agencies, but other private entities that are insisting on secure video and audio and USB transmission and detection.
Well, thank you, Scott. This is a very interesting and exciting time that we're living through, and hopefully, this period creates opportunity, and that's how we at PESA have looked at it. Opportunity to meet the demands that are required for national security, but at the same time deliver the functionality and flexibility of a platform that can take us securely into the future. Not having to forklift anything and throw it out in a year or two. And so, when we spent a year thinking about PESA Secura before we actually started to put code to enter any code, and we listened. And we're not saying we've got it perfect. There's always improvement, and we're going to learn. But I think we're trying to take that step forward while embracing our past. So with that, maybe pass it back to you, Bob.
Okay, thank you. We'll take questions now. Again, as a reminder, the Ask a Question box on your display is your portal for entering the discussion. I'll start by asking some that we already have. Based on what customers are telling you, what is the biggest challenge in moving from SDI to IP?
Scott, do you want to take that on?
Yeah, sure. I was thinking you might. That's why there was a pause. I think the challenge is equal to both HDMI and SDI. We pick on SDI because it's what we've done. But I think the biggest challenge is we've got an open standard that, frankly, and Howard and I have talked about this on numerous occasions, but I mean, we honestly did take a hard look at seeing whether or not the baseband video could be, encrypted or scrambled in some fashion or flavor. But the very architecture of how it was built from the very beginning, and I'm talking 50, 60 years ago. This goes back to analog days. The way that was actually constructed, it makes it very, very difficult to do that. And I can tell you from past experience with both broadcast and consumer, this was attempted in years past and failed miserably in almost all occasions. You remember when you used to buy little boxes for cable guys that were trying the same experiment many years ago, decades ago, where they were trying to encrypt or scramble certain signals so that you had to pay for what you viewed. They couldn't do it. Basically, a new box came out that descrambled it, and this went on and on and on. And when they finally went to the IP side, this ended, and we started using a lot more modern technology. But by and large, that I think is the biggest challenge: is where do you secure the signal, right? Because if you're starting with a signal that was envisioned to be open from the very beginning, it's extremely difficult unless you start at the beginning, which is what we did.
Yeah, if I could add to that, Scott, and that's a very interesting, perspective. I think the other aspect is, we all grew up. If you were in VDS, you grew up in a hardware oriented environment, and the world is evolving. It's software and it's cloud and it's networking, And that's forcing us as a VDS community to make the transition as well. That's exciting. That's opportunity. And it's going to allow us to respond to our user community demands much quicker, and I believe more cost effectively, using off-the-shelf, more and more off-the-shelf, the NVIDIA chipsets, the AMD chipsets, the Intel chip, the power that they encompass today compared to 5 years ago is magical, and as well as the FPGAs. So we're in a very exciting transition, and very much looking forward to being part of it.
Okay. Our next question is, what do you think about broadcast application? Can you replace the traditional infrastructure?
Yeah, I think that goes to the same answer that Howard had just said. They're very, very hardware based, and they're struggling with that. You can see what's happening in the consumer side, where you now subscribe to services that stream. These used to be over the air with an antenna, the old aluminum foil. I mean, yeah, they're free, but I think as you look about replacing traditional infrastructures, you're seeing it right in front of your eyes. I mean, this is that knock on the door. And in this case, I'll mention that the consumer's got a knock on the door. How do you want to see your programs? And I think the answer is pretty clear. And I think that's what's going to happen not only in broadcast, but it'll happen across the board. We're seeing the evolution of video changing from what used to be a very traditional hardware-based scheme to a software-based stream that's delivered direct to consumer. Or in this case, we want to isolate that, right? We want to make sure that we can keep things protected. And let's face it, in the IP domain, it's even worse, right? People can take the IP. So I think that's a challenge. We as we move forward, we want to make sure that if we have a common open architecture like IP, we need to make sure that if we have sensitive information, we've gone to as much measure and effort as we could possibly make to ensure that people can see the right video at the right time at the right place.
If I could just add to that, Scott, when broadcast sets, amongst other services, they set the expectation in our community, right? I mean, our kids or grandkids, are playing on 4K devices, our TVs, our movies are 4K 60. But yet when we go to work, we're using 720 or 1080. And that's sort of backwards to me. I mean, I think we should go to work and 4K 60 should be the starting point. And there shouldn't be an excuse for it. I mean, when we're buying systems now, even if you are only using graphics and you're looking at Excel spreadsheets and Word, I still believe you should be putting in 4K 60 or higher as a platform, because you do not want to have, in 1 to 2 years when your requirements change, you want to have the capability embedded in your platform. I think you have to look ahead. What's the world going to be like in 5 years? You want something that's going to support the growing requirements, and I can certainly tell you we're not going to be looking at 1080p on our home TV sets, let alone today in 5 years. So I think the broadcast industry has sort of driven us, within our environment to be better and to demand more of our suppliers. An example being 4K 60 should be the starting point, not 4K 30, not 1080p. I want 4K 60 because that's where the broadcast industry's at.
Okay, interesting points there. All right, well, our next question has an international flavor to it. Given the U.S. government's mandate for zero trust IT environments, how might this impact Canadian and other alliance partner, such as NATO, requirements?
Yeah, I think
that's an excellent question. Go ahead, Scott.
No, I was going to let you go ahead.
The world is the world is global. The world is global, and we need to work with our partners. This comes to the implementation of trusted platforms that are interoperable across geographic borders. We need to seamlessly be able to securely communicate and collaborate with our partners, whether it's a mission, intelligence gathering, doesn't matter. And that comes back to stovepipes and non-interoperability issues that exist today. And yes, there are platforms that are putting us, directing us in the right direction. But, I think we need to get our house in order, and we're doing that. But we absolutely need to consider, as part of the expanded and broadened environmental requirements for international organizations to be able to seamlessly integrate. And that isn't easy, but I think it's absolutely something we can overcome. And that, quite frankly, was in our design elements in 2017. This is a global world. And we have to have these architectures that can successfully and securely interoperate. That's another driver of what is driving what we believe the next generation architecture.
Howard, when you look at the stovepipes that currently exist between the Navy, the Army, the Air Force, and the Coast Guard, what we're trying to do is there's an overarching philosophy by DoD to implement a joint all-domain command and control, which are implemented by the Air Force under ABMS, by the Army under Project Convergence, and by the Navy under Project Overmatch. For these groups to work together requires this model that we're talking about, scalable and secure, and it will solve the same problem whether inside the U.S. or with the Five Eyes alliances or with the NATO alliances, because the common factor there now has been dictated by the DoD CIO. It's going to be a data-driven platform, and that data has to be encrypted end-to-end from source to glass, from the sensor to the C2, and a technology that can meet those needs will work nationally for the U.S. within our own branches of the services branches, and also designed for the allies. In fact, JADC2 philosophy, as part of its secondary mission, is the communications with our allies and the Five Eyes. And we built to that specification as part of the PESA roadmap.
Okay. Next question. How does IPVDS fit with CIPRNets, NIPRNets, and JWIC?
Those are, as we all know, those are networks, 3 different networks that the government uses to provide secure interconnectivity, and they're an important part of our infrastructure. That is a big benefit for the use of an IP-based solution, because that means you have an opportunity. You have an opportunity to run VDS applications across those networks. Now, of course, there are bridges to be crossed to get onto that network, and basically, it's not just a free ride. You have to do things properly. We are very keen as an organization, PESA. It's one of our 2022 objectives as we are continuing to roll out our platform, is to have a department that would like to see our platform on one of those networks, and to define a project with that. So we are, Bob, we're very keen to make that happen in 2022.
Okay then. Well, we're out of time. That concludes our Signal Media webinar for today. I want to thank our experts for their presentation, and thanks to all of you for joining us. Our presenters will try to respond directly by email to any unanswered questions in the queue. Now, you can also link to the archived version of this webinar, along with previous Signal webinars, on the Signal Magazine website at www.afcea.org/signal/webinar. This has been a Signal Media webinar sponsored by PESA. Thank you again and have a good day.